In the last video, we saw some methods of string, and these are just a few of them. A lot of them are available. We just discussed some of them. In this video, we are going to talk more about strings in a particular way. For example, what if you want to find out whether a particular substring is there in a string or not? Let's say you have a string and you want to know whether a particular substring is there inside a string or not. Well, you can easily find out that using the in keyword, and similarly not in means the reverse of that, or the complement of that or not of that. And in keyword always will return either true, a boolean, or false. If it is inside the string, it will return true. If it is not inside, it will return false. So let's check this, the implementation of that in Jupyter Notebook. So let's see. So let's say we have a string ABC, and we want to check whether this string is there in this particular string or not. So the return value is false because ABC as a substring is no longer there. A is there, for example here, AB is here, but ABC is no longer there. Yeah. So if we, for example, have an ABC somewhere at least once, then the result will be true. In the last to last video, or maybe in the very first video for strings, I showed you that you can use plus with strings. Can you compare two strings using less than or equal to? I mean, how to compare two strings, whether they are same or not. For example, ABC, let's say that's a string ABC. I want to check whether that string is the same as ABC or not. What will be the result? So the question is this double equal to can be used for comparing two strings? Well, the answer is yes. What will be the meaning of less than? A string is less than the other. Is that true? For example, ABC is less than, let's say, DEF. Is that true? If it is true, for example, what does it really mean? How can we define one string is, this string is lesser than the other string? Maybe this operator is working based on the length of the strings. But even if that, then this length is the same as this length. And to be more precise, we can change that length, for example, by just saying okay, ABC, DEF, GHI, and I guess this string will be still smaller than the right string. So how this comparison is working? Well, I guess the comparison is working based on the alphabetic order, and you know the alphabetic order. A becomes first, then B, then C, and all the alphabetic order that is there in English dictionaries. That's how the strings are working here. And the alphabetic orders for all the special characters will also be defined in Python. For example, that's a special character. For example, maybe this string. Is this string smaller than the following string? Yeah, return true or false. Because there is particular ordering in Python that is defined for these characters, that this becomes first and this, like A becomes first and B, B becomes first and C, and so on. So whatever the alphabetic order is, based on that order, you can compare the two strings, no problem. So these are also available. And the third thing is in function, that is also available to check whether a particular string is inside, a substring is inside or not in another string. One more thing that I want to talk about in that, for example, what if your goal is to print the following? Let's say you want to print the following: we are learning, and let's say you want to print the string in double quotes. We are learning string here. Let's say you want to print this. You want this string to appear in double quote. How can you do that in Python? Well, it looks like same. What's the difficulty? Let's call the print function, and then just write here we are learning then write the double quote here, string, and here. That's it. But there is a problem. The reason is when we call this, when we write this double quote, actually the string ends here. Exactly, the string ends here. And when we write this single quote and this double quote, another string starts here. And this is no longer a string. I mean, it has no data type inside. Well, how can we then insert these double quotes inside? Well, there are several ways. One way is to use escape sequence, and escape sequence is just like, it is, you use a slash and then whatever you use is considered as a character inside the string that is you're using. And now if you want another double quote, you use a character which is the backslash or maybe a forward slash, and if you use that, that means whatever that is coming in front of it should be used as it is, rather than considering that that's a special string defining symbol. Now in this particular case, you'll be having your double quotes available, and the backslash will be just out. It is just defining that don't touch this double quote. It has nothing to do with defining a string. It is just because I want to highlight this word. Another more easy way is to use the single quotes. For example, we are learning, and use the double quotes as a character inside that. Now the single quote, wherever it starts and ends, they define the string. Everything else is a character. We do not need a escape character where we want. Okay, great. And there are a lot of escape characters. For example, we have we are \n. That means go to new line. We are now on another line. So this \n actually puts everything that comes after to a new line. That's an escape character. Similarly, we have an escape character \t that actually inserts a tab whenever we want. So if we are, then a tab, then now on another line, now on another tab, whatever. So there are a lot of escape characters. I mean \n, \t, there are other. So it is good to know those. One more thing that is important. For example, let's say you want to print some address on the drive. Let's say C \backslash or forward slash, whatever that is called, name \drive. Let's say you want to do that, and your goal was to just print that path. What will happen is this \n will be treated as a new line escape sequence, and \n will tell, okay, go to the next line and treat the rest of the things. But because \d is not any escape sequence, it is not listed inside, it is treated as it is, and that way this slash is also treated as a character. But here, because if this slash followed by this n, that's a combination that is already there for a new line, that is treated in a different way. If you want this to be used as it is, and you don't want this behavior, you just want that all this should be treated in a very literal or raw sense, then you should just apply an R there, and R will tell, okay, that's a raw string, everything inside, just treat that as a raw string. There is no escape sequence inside. Great. So and there is much more about string we can talk, but that was the most important that I told you, at least to me. We can explore this more. Actually, you should now explore this more. What are other functions of string? How can we play with strings in another way and stuff and so on. If I talk about strings, I can just I can give a whole course on strings as well, but here I just give you a snapshot of strings. If you need more about strings, you should be searching on internet or seeing documentations and seeing basically what you want according to your requirements. Search the functions. Probably they will be available. Okay. In the next video, we are going towards list, tuples, sets and dictionaries, some other data structures that we were talking about earlier. We will be going to explore them in more detail from the next video. Hope to see you in the next video. A data structure, informally or in a very naive sense, is basically a collection of a lot of basic data types that contains data. One structure contains a lot of data, and we can define sometimes several methods, and several specialized kind of functions are customized and defined just because of that data structure to perform efficiently. Different kind of for different kind of tasks we may have to define, or we may have to choose different kind of data structures. The basic data structures that are available in Python is a list, tuple, set, and dictionary. These are the basic data structures that are available. We can create our own data structures if we want to, but most of the problems, almost all of the problems, mostly they are solved by these four basic data structures. Although a lot of these are not that efficient, there are efficient ways for customized kind of problems. We will see that efficiency when we will deal with the package NumPy that is faster than all of these. But we will see what kind of constraints are there to make it faster. Anyways, data set in a very loose term is collection. It is collection of a lot of values, a lot of data inside. And all these data structures, list, tuple, set, and dictionary, they are collection of data of heterogeneous types, which means one value can be integer, another element, let me call an element, another element or item. Another item or element can be of string type, another element can be of, let's say, floating point number, another element is a whole list itself, another element is a tuple, and so on. So different elements can be of different types, and that makes this heterogeneity, that makes these four data structures much more applicable and much more abstract, and they can be applied to almost all the problems. So let's see one by one and let's compare them together, because the best way to understand four of these is just to compare them, which can do what as compared to the rest. So let's compare them and learn how can we use those in detail. So list, first is list. List is ordered. Ordered here means it is indexable, which means there is the element number 1 is at position 1 element. There is an ordering of elements, first element, second, third, 25th element. There is an ordering of element with respect to their position. So that's what we mean by ordered. Changeable, or sometimes called more reasonable term or more usable term, is mutable. Mutable means once the list is created, as contrast to string, once the list is created, you can change its elements. For example, you can change the third element with another element, and that's perfectly fine. You can change it. That's what we mean by changeable, or more popularly called as mutable. Duplicates means the list can contain more than one element more than, at the position number 3 you can have the same item, and position number 5 you can have the same item, so the duplicates are allowed. Tuple, however, although ordered, there is an ordering of elements, there are indices of different elements. This is immutable. You can, once tuple is created, like strings, once the tuple is created, you cannot change different elements in the tuple. You have to create a new tuple if you want to, but you cannot change the items in the tuple, and the duplicates are allowed again. Set, on the other hand, is unordered, which means there is no indexing, there is no positioning, there is no first element, there is no third element, there is no fifth element. That's a collection without actually indexing. Because you cannot access a particular element with index, you cannot change it, but what you can do you can insert more elements, and you can remove existing elements if you want to. Again, the set, like in mathematics, sets does not contain any duplicates, so one item appears just once. We will see the examples. Dictionary, a very, very, very powerful data structure. Again, dictionary is just like a set. It is a set, it is unordered. Again, changeable, you can change them, you can change the items, and the dictionary, and it does not have duplicates because it's basically a set. It is just like a set. The power of dictionary is each item consists of a pair, and one value in the pair is called key and another is called the value. For example, val is key for 12, name is key for band, and so on. So we have seen this dictionary before in loops and stuff in just a very loose way, but that's really a very, very powerful data structure. And later on we will see in pandas, basically all the data is basically managed just like a dictionary. If you have a good knowledge of dictionary, you'll be having a very good grip very quickly on a big data science library or big data science package, which is called pandas, because each and everything in pandas is handled just like we are handling a dictionary. So it's a really powerful data structure to know about. So so list is mutable, dictionary is mutable, set is mutable in a sense that you can insert and remove elements. Tuple is not mutable. And that's the comparison theoretically what is there. All these types, each and every of them is a collection of different values, and the values can have different types. That's the abstract power of all these data structures. So in the next video we will actually try to get a good grip on list, tuple, set, and dictionary, and we will actually define them, code them, access different methods of those, and we will be trying to become comfortable with these data structures by coding them in Python. So hope to see you in the next video.